Okay guys, let's do it. We're gonna fix that test. Okay, so you may or may not need a separate piece of paper. I'm gonna presume that probably you do. So a Gallup poll interviewed 1,600 people. Of these, 18% say they jog regularly. Okay, so my p-hat is 18 over, no, my p-hat is 0.8. So how did they calculate the p-hat? That must mean they must have talked to a certain number of people and 18% of the 1,600. So what does that mean? Okay, well, of means multiply, so 18% of 1,600 means that you know that was 288 people said they jog regularly. That's not a lot of people out of 1,600, but quite a bit. A news report added the poll had a margin of error of plus or minus 3%. So, what does this mean? All that we know, we can't take our sample. Now that we've learned significant test, we should actually be learning here that we can't take our sample as the honest to God truth. All we know is that this sample helps me know that we're 95% confident that within plus or minus 3%, this would give plus or minus 3%, if that makes sense, okay? Now, does a confidence interval mean that the percent of the population who jog is certain to be that? No. In fact, that's the whole idea behind only being 95% confident. I'm not certain. I'm actually admitting to not being certain. So the minute I saw that word certain, I knew that one was out. So that one, done. No good. 95% of the population jog between there and there. No, it's, this is the percent of people that jog. And that's your confidence level. So this one is completely preposterous. 95% of the population. No, no, no. You're trying to say that somewhere between 18 plus or minus 0.03, so that is the 15 and the 21. That's where they're giving. They created an interval from 15 to 21, and you're 95% confident that the truth lies somewhere in that interval. You don't know where it is, right? It could be exactly this. It could be this. It could be that. It could be this. All you're saying with a confidence interval is that you're 95% confident it falls somewhere in there. We can be 3% confident? No. That's not what a confidence interval means. If Gallup took many, many samples, 95% of them would find that 18%, no. If we took many, many samples and we created many, many intervals, then 95% of those intervals would capture the truth, whatever that is. 95% of them would capture the true proportion of the population that jogs, which we actually don't know. We've only talked to 600 people. We haven't talked to the whole population. But we are sure that since we talked to that many people, we're 95% confident that whatever the truth is falls in this interval. That's all you're ever saying with a confidence interval. Okay, and we generated it using probabilities. We generated it using probabilities by saying, what if we told the computer the truth was this and then worked backwards? What kind of intervals would we create? Okay, so we proved it using probabilities. That almost all of the intervals we would create with sampling data as least as large as 1,600 would 95% of them, if we generated this, 95% of them would capture it and 5% wouldn't. Okay. Wow. 4-minute explanation, 1 question. So let's get to question number 2. But again, that question is kind of summarizing everything in this chapter, all right there. Question number 2, an agricultural research plants 25 plots with a new variety of corn. A 90% confidence interval for the average yield of these plots was found to be 162 plus or minus 4. Which of the following is a correct interpretation of the interval? We are 90% confident that the interval from blank to blank captures the true average yield. That is our script. That is exactly what we're supposed to say at the end. So let's just verify these numbers. If I take 162.72 plus the 447, then that's my number. And if I take the 16272 and subtract the 447, that's my number. Close to my number. Okay. Next question. 3. I collect a random sample of N from a population, and from the data collected, compute a 95% confidence interval for the mean of the population. Which of the following would produce a wider confidence interval? So remember I said with weather, I collected a random sample size of N. So let's say I talked to 100 people, or I collected 100 data points of weather and temperatures in the previous years, okay? And then I said, okay, I'm 95% confident that based on 100 weather data points I picked from previous years, I'm 90% confident that today the interval of temperature would be between 70 and 90. Okay. Now, which of the following would produce a wider confidence interval? Well, if I increase this to be 99% confident, then if I'm going to have to be that sure, then I'm going to have to widen this a little bit, right? Maybe I'm going to be less accurate in my guessing, but that's how I would increase it. How else? Well, I could, if that's not allowed, I could go out and look up more previous weather points. So if I increase N, if N increases, then I have many, many more data points, and that should also increase. So A tells me use a larger confidence level. That's exactly what we talked about in class. This won't work because A will work. Use the same confidence, but compute the interval N times. No. Increase the sample size. So this should increase it as well. Wait, no. If I increase N, that's going to give me more accurate data. So I can continue to be 95% sure, and I actually would be able to be more precise. So I might be able, if I increase N, I might be able to provide more precise information. So it's like, oh, I went and pulled up 1,000 data points, and now I could tell you with the same amount of 95% confidence. You see that? So, right? If I increase N, I get more accurate. I can kind of narrow that. So to make it wider, I could reduce. Reducing sample size would make the confidence level wider. All right. So there you go. It's definitely A. It was A already off the bat, but hopefully we've made sense of why increasing N gives you more accurate data, which actually in effect narrows the width. Question 4. A marketing company discovers the following problem with a recent poll. Some people refuse to ask the question. That's a problem. Not a condition, just a problem. People without telephones could not be in the sample. All right, that's also a problem. Some people never answered the phone in several calls. That's also a problem. Which of these is the source for the margin of error? No, the margin of error is the variability of the data. That's if all the data was collected and everybody gave it freely, we still have a margin of error. So this margin of error are not data design errors. The margin of error is based on variability. So E, none of these are the sources of this margin of error. They are mistakes of design. Okay. Some avoidable, some unavoidable, but they have nothing to do with why it's a margin of error. Okay, 5. You were told the proportion of those who answered yes to a poll on the internet use is 0.70. The standard error is this. Okay, what's the sample size? So let's say this is a proportion question, right? So we have p minus 1 minus p all over n, take the square root. So we have 0.7 times 0.3 all over how many people did I talk to? You are told the standard error is this. So can we solve for n? Okay, sorry about that. You weren't able to see. So this is a proportion question, right? So we know this is the formula for the standard deviation, and this is the information we have, right? So let's do some algebra, guys. We square both sides. So now this is still there, and this side's squared. These we can swap, right? These we can swap spots. So put this one up here and this one down here. This is just 0.7 times 0.3 is merely 0.21. So that's what n is. So let's figure that out. Typing it into the calculator, 0.21 divided by parentheses 0.0459 squared. Enter. 99.67. Yeah, so that's not going to be enough. We must round up to 100. There's my answer, guys. That's how 99.67 would round up to 100.